but the slope will be different. Does anyone remember what is the relationship between two lines that are, the slopes of two lines that are perpendicular? When
Negative inverse?
Yes, negative multiplicative inverse. So if the slope of the tangent is negative 3/4, what will be the slope of the normal line at that point? 4/3. Very good. Awesome. Who said that?
Sure.
Thank you. So all I have to do in order to determine the equation of the normal line now, this is still 0, this is 1, so it's going to be 4/3 x minus 1. So y equals 4/3 x minus 1, and I will change it into 4/3 x minus 4/3, and this is the equation of the normal line. And we combined two questions in one. Okay, let's see if there is anything else that we want to. We can come back. Okay. Yep, something like I would like to find the points on a curve where the tangent is horizontal. Okay, so let's also look at, I'm going to pick one. Then I'll let you pick again, of course. So here we want 59. So I'm just going to copy y equals x cubed plus 3x squared minus 9x and plus 10. So we talked about this in the past. When would a graph have horizontal tangents? When will a graph have horizontal tangents?
When it's going to infinity.
You're talking about vertical. You're talking about vertical asymptotes? We're talking about horizontal tangent. Something like this. Or something like this. So a graph will have a horizontal tangent at a max or a min, at the peak or a valley. So either at a max or at a min. What does that mean? So what is the slope of this line and what is the slope of this line? So the tangents, if they are horizontal, forgive me.
Slope is 0.
Excellent. But what do I know about the slope? How do we get the slope? If we have a function, how do we get its slope, so to speak? What do I have to determine first?
The differential.
Very good. So I have to find its derivative. Remember 3x squared plus 6x minus 9. What do you think we're going to do next? With this. This is the slope, right? What am I going to do with it in order to find the points where the function has horizontal tangent? Yes, Sean, give it a try. It's okay.
I mean, in this case, I'd just be guessing, but we're trying to find the max and min.
No, we're only trying. If you want, yes, you can say that, but we don't know whether they're max or min. That's what that was the point I was making. But I need to determine these points, but I will not be able to tell you which one is max min at this point. But how do I proceed? I have the derivative. I know that the derivative gives the slope, and I know the slope has to be 0. So how do I continue then? What do you think? Anyone? Yes?
Make y prime equal to 0.
Exactly. Thank you very much. That's what we need to do. In order to determine the x values here, the x value here and here, of course. Or as many, I don't know. It's a quadratic, so I'm expecting 2 options. So then 3x squared plus 6x minus 9 must equal 0. Awesome. So please remember, the derivative has to be 0 when the function has max or min. Okay, how do I proceed here? Can anyone give us a first step?
Would you use a quadratic formula?
We divide also, always simplify and factor. Always, they should be in the back of our mind because it makes our life easier. So we have x squared minus 2x minus 3 equals 0. No, it's plus here, sorry. So 1, 2, and negative 3. And if I can factor, I have nothing against the quadratic formula. If it takes more than 10, 15, 20 seconds to factor, then of course, quadratic formula, I'm not going to waste my time. Can anyone factor this for us?
Plus 3 and negative 1.
Thank you very much. So then x equals and x equals, anyone?
Negative 3 and 1.
Excellent, well done. So let's say a p and a q. So p has x coordinate negative 3, q has 1, but we're asked to find points. So how do I find this?
Do you plug it back into?
Absolutely, in the original function. Thank you very much. So I have f of negative 3, which is negative 3 to the third, plus 3 times 9, plus 27, and plus 10. And then f of 1 will be 1 plus 3 minus 9 plus 10. Okay, so let's say what this is. So this is negative 27 with 27 will go away. 18, so 28. And what do I have here? So this is 14 minus 9, I think it's 5. So we determine the points where the given function has horizontal tangents. Good. Good job. Okay. There are other types of problems, but I have to move on. And we can go back and do other things later. Okay, so 3.2 deals with the product and quotient rules. Notice that I have not shown you anything like a function multiplied by another function prime. And so far I did not show you this, a function divided by another function prime. So these have to be memorized as we present them. Do not try anything else. So I'm going to call this function 1 and this function 2. I'm going to call this function 1. I'm going to call this function 2. So you see the pattern. 1 prime times 2 plus 1 times 2 prime. Your book twists some of them. You can use the formula you like. I just like to keep them in the same order all the time. 1, 2, 1, 2. But you can twist this, whatever you want. But this is it. Now the ratio is exactly the same at the top but minus in the exact order that you see it over there. And the denominator is not differentiated, it's just squared. So let's apply this in as many problems as you want. Feel free to choose. Okay.
And number 8.
Which one?
8.
The number 8. Let's start with number 8. Perfect. Perfect pick. So g of x is a product of two functions. Perfect. So this is function 1 and this is function 2. Even if you distribute, you'll still have to apply the product rule twice. Oh, now remember this, because I would like us not to have to go back to it, but if we need to. Does anyone remember we did this with the definition of the derivative, and we have to memorize it moving forward? So the square root of x prime. Anyone can give us any that? We proved it a long time ago. So this was 4, so this is 5. Anyone remembers the square root of x prime?
Is it 1 over 2 and then square root of x?
Excellent, thank you very much. Awesome. Good, so this was carved in stone a long time ago. So then g prime, I have to differentiate this function first. X prime, how much?
The 1.
Thank you very much. Plus 2 over 2, the square root of x. 2 to the square root of x multiplied by the second function. I have this here. I have this here. Now plus. I copy the first function. And how much is e to the x prime?
E to the x.
Thank you very much. You can leave it alone. You can factor out e to the x if you want to. So here I have 1 plus 1 over the square root of x plus 2 the square root of x. Yes, you could find the least common denominator. Can anyone give us the least common denominator?
The square root of x.
Very good. So then this one needs a square root of x. This one needs a square root of x. This one needs a square root of x. I cannot do anything more. So the square root of x plus 1 plus x, the square root of x, and plus 2x. So that's what I said. We can leave it alone. We cannot really simplify it. Good pick. It was a good example. Good. Anything else? We have to illustrate with ratio anyway. Quotient. This is not a quotient. This I can simplify because the denominator is just one term. This is a different situation. This is a different situation. These are all functions
13?
that, say it again.
Can you do 13?
Let's do 13, very good. Let me copy it. F of t equals 5t over t cubed minus t minus 1. Perfect. Notice that the numerator, don't write that, don't change anything. But if I have here, let's say plus 2, I will not be able to do what I'm going to do. But the numerator is a constant times a function. Remember, always simplify, factor, simplify. So I'm going to leave 5. So this can be rewritten like this. Only because it's multiplied. If it were a positive or negative, no, you cannot do that. But it's a factor of the numerator, and it's alone. This is one term. If I have another term, I cannot do this. Why did I do that? Because it's easier if I keep this factor outside. It will patiently wait till I finish differentiating this. Why? Because we already discussed this. If I have a constant times a function prime, the constant stays outside, and I have f prime to deal with or worry about. So if that's the case, then this is my page 6. Okay. So if that's the situation, then I have f prime of t equals 5.
I have a question.
Yes, I'm ready.
With the 5, factoring out the 5.
Mm-hmm.
Would you be able to do it in the same situation with where like you would add 5t squared plus 5t, would you still be able to remove 5?
Yes, as long as all the terms at the top, as you just mentioned, gave the example, perfect example, thank you.
Okay.
Yes, always. Because the numerator can be written as 5 times a function. Very good, good question, thank you. Perfect. So now I'm going to copy the denominator immediately because I know I don't have to differentiate it, it's squared. And the numerator, when I differentiate this function, what do I get?
1.
Very good, so I don't have to write it. Multiplied by t cubed minus t minus 1 minus the top. Now I need to differentiate this function. Can anyone help?
Is 3t squared minus 2?
So minus t prime is -1 and -1 prime is 0.
All right.
Is that okay? Good. 5
Yeah.
stays outside, and then I have t cubed minus t minus 1. I distribute minus 3t cubed plus t over t cubed minus t minus 1 squared. Luckily, these two go away. T cubed minus 3t cubed. 5 can still stay patiently outside. Negative 2t cubed minus 1 divided by t cubed minus t minus 1 squared. Yes, I can factor out a -1, and I like to do that. So 5, 2t cubed plus 1 over t cubed minus t minus 1 squared.